We're going to take a look at the types of discontinuities. Okay, so the first one we're going to look at is jump. Go ahead and copy that down. Pause the video and copy it down. So we can see the endpoint is 1. It's going to be an open circle because there's no equal next to it. And numbers less than 1 are 0, -1, and 2. So now let's plug those in. So at 1 squared plus 2 is 3 plus 1 is 4. 0, you just don't get 1. -1 squared is 1. Minus 2 plus 1 is 0. And you plug in -2, you're going to get 1. And you have a closed circle and for numbers greater than 1. So plug those numbers in. When you plug those numbers in, you're going to get -1/2, -2/2, which is -1, -4 divided by 2, which is -2, -6 divided by 2, which is -3. So all we're doing again is just plugging it in. So we're going to go ahead and plot this. So on my x direction, I've got -2 to 6. On my y direction, I've got -3 to like 4. So just go ahead and make a graph. This is a listening check. This is a listening check. Color in where it says y, and then it says -1/2. Color in the -1/2 by the y. Alright, so let's go ahead and plot these points. So we have an open circle at point 1, 4, open circle. 0, 1, -1, 0, -2, 1, and that obviously we know is a parabola anyway, so it goes something like that. We don't have to plot that one. Closed circle at 1, -1/2. Next point is 2, -1, 4, -2, 6, -3. And this is a linear function. Alright, so I've gone ahead and plotted it. Now for a function to be continuous, these three things must happen. So it has to be defined at 1, and you can see it's defined at 1 because it's a closed circle, it's -1/2. The limit as it goes to that number must exist. So we're going to take a limit, we're going to look at the limit from the left and the limit from the right, and if both of those are equal, then the limit as it goes to 1 is existent. So let's take a look from the left. So we can see that that goes to 4. The limit from the right, so the graph comes from the right hand side, we can see that that goes to -1/2. Are those two limits the same? No, they're not. So if the limits are not the same, then it does not exist. This next statement is going to be a listening check because I'm not going to write it down. So you need to listen to what I'm saying. So a jump discontinuity exists when the function is defined or not defined, f of a, but the limit does not exist. So make sure you say is defined or not defined. Note, it's important to know that even though the limit doesn't exist, the limit from the left and the limit from the right exist and are finite, but they're not equal. In other words, they go to a certain number like 2 or 10 or whatever, but they're not equal. But if you're given a graph, say you're given this, so go ahead and copy that down. Pause it, copy it down. You still have to find these three things in order for it to be continuous. So looking at the first one, is it defined? Yes, it is, because it's a closed circle at f of 3. Now, what about the limit? Does the limit exist? So you're going to take a look at the limit from the left, the limit from the right, and then if those two limits are equal, then the limit exists. So let's take a look at the limit from the left. As we go to 3, so we stop at 3, from the left hand side, we see that the graph goes to 2. As we go to 3 from the right hand side, we stop at the ruler, we can see that the graph goes to -2. Now in order for the limit to exist, both the left and the right have to be equal. Are they? No. So the limit does not exist. That's what is a jump. So again, the jump discontinuity is defined at f of a, but the limit does not exist. Let's take a look at a point. Pause the video, copy that down. Alright, so x is less than 3. Numbers are less than 3, open circle because it's not equal to. So those are numbers like 2, 0, -1, -2. Alright, so let's go ahead and plug it in. You're going to get 30, 4, 16, -8, 12. 0, you're going to get 0, -1 squared, -1, 4 plus 2, 6, -2 squared, and so forth, you'll get 20. Alright, what about for the second function when x is equal to 3? So x is only equal to 3. So I go x is equal to 3, plug it in, 3 times 10, 30, minus 1, 29, and it's a closed circle because it's equal. This is a listening check, color in 29, color in 29. And the last one, whenever x is bigger than 3, it's always equal to 30. So we're going to go ahead and plot that. I'm going to go up in tens because of space. You can make your graph whatever you want it to be. And open circle at 330, then 212, that's around there. 0, 0, -1, 6, about there. negative 220 around there, and we know it's a parabola because it's x squared, a quadratic. Alright, so then at this point when x is equal to 3, it's 29. So it's closed circle at 3 and 29. And then any number bigger than that, it's going to be equal to 30. So open circle at 3 and 30, but everything after that is always 30. So it's a straight horizontal line. So that's what we looking at. Actually, we've done this before, so we know it's not continuous, but we're going to take a look at another example. So I've already shown you why it wasn't continuous in the beginning, but let's draw this. Pause the video, draw this. Just make sure you have those points. And then let's take a look at why it's discontinuous. So is f of a defined? Meaning when you plug in 4 where it's, got the little hole, is it defined? Yes, because I have a closed circle, so it's negative 3. Does the limit exist? In other words, when you take the limit from the left, you take the limit from the right, are they equal to one another so that the limit as x goes to 4 exists? So let's take a limit as it goes from the left. So I'm going to put a ruler. From the left, as the graph goes to this ruler, what's the y value? So as I go there, the y is 1. From the right, the graph goes towards 1 again. So the limit from the left and the limit from the right are equal, therefore the limit exists and is 1. Alright, the last thing in order for something to be continuous is the limit equal to f of a, where the function is defined. So let's take a look at it. We have negative 3 and 1. Those are not equal, therefore f of a is not equal to the limit as x goes to a of f of x. So point discontinuity occurs when the limit exists as well as the function is defined, but they are not equal to one another. That's a point discontinuity. So a lot of times you're going to be asked what kind of discontinuity it is, and you have to know these different things for them. So let's actually skip over essential and take a look at removable. Pause the video, copy that down. So the thing about removable is you can factor, most of it is factorable, and that cancels down to x minus 2. That's the definition of removable, meaning I can take out 1. So x minus 2, the graph like x minus 2 is just f of x and then move it down 2. But I'm going to go ahead and sketch it out just because I know what it is already. This is a listening check. Put a box around x minus 2. Box x minus 2. So parent is f of x and then we're going to go down 2. So it crosses the y-axis at negative 2. And then the slope is 1 over 1. So it's 1 up, 1 over, 1 up, 1 over. And then just draw a line. 1 up, 1 over. Okay, so it has a removable discontinuity because we canceled x plus 1. So when x plus 1 equals 0, x equals negative 1. That's the removable one we took out. So we could draw the graph. Alright, so let's go through our 3 things in order for something to be continuous. Is f of a defined? Is f of negative 1 defined? So if I look at my graph, it is not defined because at that point I'm going to get a 0 in the denominator. Alright, the second thing is, does the limit exist? So limit from the left, limit from the right, are they equal to one another? So the limit as it goes to negative 1 from the left is going to be negative 3. And again, all you got to do is just plug in negative 1 into the original function. The limit as it goes from the right is also negative 3. Therefore, because the limit from the left is equal to the limit from the right, the limit does exist and is equal to negative 3. Then the last thing is the limit equal to f of a, so a function being defined? No, it's not, because there's nothing that is defined. So I can't look at that. So a removable discontinuity happens at x equals negative 1, which is when f of a is not defined, but the limit exists. So a removable discontinuity is f of a is not defined, but the limit exists. Alright, let's take a look at essential. Pause the video, copy that down. Alright, so I'm going to go ahead and factor this out and see if I can cancel anything. Because I remember when we did vertical and horizontal isotopes, you had to factor, reduce, and then set the denominator equal to 0. So let's go ahead and do that. So I factored out and it didn't help, but I set it equal to 0 and I got x is negative 2, which means I get a vertical isotope at that. Now this is what the parent looks like. So I'm going to graph it off the parent, but I'm also going to remind me in class to teach you how to use a calculator. So this is what the parent looks like. And then because of the negative, I know I'm going to flip it out. It's outside, so you would think y, but it's really x. So I'm going to flip over the parent graph over the x-axis. So again, I draw what it is. And actually I'm going to flip that line too, because when you flip it over the x-axis, that line's going to change. So it's going to flip over. So it looks something like this. And then draw your graph. Now that's flipped over, but you also need to make sure it has a vertical isotope at -2. So go to -2, that's where your vertical isotope is going to be. So the graph looks something like this. But again, I'll teach you how to graph it with a graphic calculator. Alright, so let's take a look at whether it's continuous. So is f of a defined? No, because it's not, no, f of a is not defined. You plug it in, you're going to get 0 in the denominator, and that's wrong. Alright, does the limit exist? So let's take a look at the limit from the left, the limit from the right, and are they equal to each other so that the limit exists? So the limit from the left, if you come around the graph, you can see it's going to go to positive infinity, it goes up forever. The limit from the right, when you come to the graph, you can see that it goes down forever. So that's negative infinity. The limit does not exist because they're not the same. They're not both going to infinity or negative infinity. So the limit does not exist. Well, to have an essential discontinuity, both f of a is not defined and the limit does not exist. So both f of a is not defined and the limit does not exist. Again, it's important to note that in essential discontinuity, one or both the left-hand limit and the right-hand limit don't exist or are positive and negative infinity. So again, this is the big difference between jump and essential. Jump, the limits go to a finite number, and essential, they go to infinity. Let's take a look at an example where you can have a combination of two. Alright, so again, I'm going to factor out, see if I can cancel some stuff out. So I'm going to do the box method. First time in the first box, last time in the last box. Then 2 times 15 is -30. Find two numbers that multiply -30 and add to -7. That's 3 and 10. And it's going to be -10, +3. Order does not matter. Greatest common factor, which is 2x. So that means it has to be x on the top. And that has to be 3. And that has to be -5. And check the last box. Perfect. So it simplifies to that. Factor the bottom two numbers that multiply to -20 and add to -1. That's going to be 5 and 4. With the 5 being negative and the 4 being positive. So we got a removable discontinuity because we can cancel out. And then we also have an essential discontinuity because we can set that denominator to 0 to get a vertical isotope. So x plus 4 equals 0, that means x equals to -4. So we have two things here. A removable discontinuity at x equals 5 and an essential discontinuity at x equals -4. So it is possible to have both of these together. The listening check, underline x equals -4. Alright, so that's pretty much it. So remember, for it to be continuous, the three things have to happen. For it to be a jump, the limit does not exist. For it to be a point, the limit is not equal to what you plugged in. For it to be essential, both the limit doesn't exist and it's not defined. And for it to be removable, just f of a is not defined. You do need to remember what those are. So let's practice.